The fact that something so insignificant like a cauliflower could be related to something so significant like dark matter is so fascinating. It tells us that universe is willing to share its secrets. It's just we who are too distracted. Just like you and me, a cauliflower has its own secrets. Let's decode them. Take a thin wire, a flat sheet, and a cube. Now, when we scale the wire by a half, its mass also went down by a half. Similarly, on scaling the sheet by 1/2, its mass reduces by 1/4. And on scaling the cube by 1/2, its mass reduces by 1/8. Notice that for each of these, the factor by which mass changed is an integral power of 1/2. In fact, this integral power is the object's dimension, which gives us this formula. Now let's do the same with our cauliflower. Scale it down by a half, and the mass we get is 1/6.17 of the original mass. Putting the values in the formula, we get the dimension of cauliflower is 2.62. Why do you think the cauliflower has a non-integral dimension? Maybe because of its shape? Well, that's close. Now just take a look at the sketch. Can you see what it took to produce what you see? The answer is endless repetition or iteration. The basic idea is that as you zoom in and as you zoom out, the object looks the same. This is called self-similarity, which is evident in rivers, trees, lightning, blood vessels, and even in dark matter, where its every branch looks like the whole structure. Just like cauliflower, these shapes also have non-integral dimension, also called their Hausdorff dimension. But why should I know what an object's Hausdorff dimension is? How is it important to me? Well, that's a good question. Hausdorff dimension provides us a way to capture roughness. The rougher the object is, higher its Hausdorff dimension. Another important thing to notice in these self-similar shapes is that their Hausdorff dimension always exceeds the topological dimension. So what do you call an object that has all these three properties? Well, I have to check that out. Wait, let me check. Well, you call that a fractal. Amazing. I will never look at the cauliflower the same way.